Hello, now I'm going to talk about testing the complete system. So we have done unit testing, you have test the objects, then you tested the components together, the interfaces, maybe complex modules that we developed by the different teams. But now you want to test the complete system. So now you can even test from the point of view of the requirements and expectations of the user. So how can you do it? So actually there are different phases about doing this and with different people involved, okay? So we're going to do these are going to only not only test the functionality but the non-functionality as well. So testing, for instance, performance or scalability, okay, of the system, robustness, fault tolerance, things like that. So you test it. Of course, you are guided by what are the requirements. Okay, so and the important thing is that, for instance, in terms of non-functionality, the non-functionality should be always tested in the context of functionality. So you cannot say, for instance, when you test non-functionality, say that, oh, I want to that every transaction takes 1 second. No, maybe you need to say, well, I want that this type of transactions take these or up to 500 milliseconds. But other type of transactions, so actually, sometimes we look at non-functionality for like performance in a too abstract way. Actually, when you are tuning a real system in terms of performance, you or any other non-functional quality, basically you need to define in the context of the real usage of the system. Okay. So, who's going to be involved in this testing the complete system? Okay, who's going to be involved? Basically, you have the developers that test the system from a certain perspective, as I told you. Then, as I will tell you, and then you have the quality assurance team and the users, and they test in different perspectives. Okay, so when it's the developers that are testing the complete system, they look at the requirements. Okay, they look at the requirements, at the requirements document. So they are actually doing a verification. But although they test the functionality and the non-functionality, they try to find bugs. They keep trying to find bugs. So they are the developers, and their main goal is where are the bugs of the system. Okay. So the same type of functionality that you are testing, when is done from the point of view of the quality assurance team, okay, then they test it from the point of view of the business value. So they are closer to the business and they look, so they are not looking for bugs anymore. So in some sense, these occur a bit after the developers that have just delivered the system, say, okay, we believe that this doesn't have any relevant bugs, or at least it's available to be tested from the business value point of view. So as you can imagine, there are completely different ways of doing the same, testing the same functionalities. Okay, so even the type of usage you're going to define how to test the system is going to be different, in the sense the idea is much more in the perspective of the business. Okay. And so it's two ways to do this. So how do you define these scenarios of use? Okay, basically you look at the requirements, you look at functional requirements, and you try to find combinations of functionalities, for instance, that describe a particular use of the system. Okay, use case can be an example, but you may say that, well, the way a human interacts with an ATM is not just one functionality. Usually there are a sequence of functionalities. Why this is relevant? Because it's the way it's going to be used. So if you define the particular types of use, the particular types of scenarios of use, and you test them, the system will be more reliable, or you have the confidence that will be more reliable for the way it is going to be actually used. Of course, then you should also test them for foolproof usage, okay? In the sense that if it is not the common, if it is robust enough, but this is always a trade-off, okay? It's more important that is for the typical scenarios of use because it's going to be more. Then it depends on the criticality of the system, because if the bug really or the failure that is not tested and the error can occur, it implies a big damage in the system. But again, it's a matter of cost benefit when you do this. But of course, it's normal that the team spends more time in the typical scenarios of usage. Okay, and then when you test them from the point of view of non-functionality, for instance, you use these operational profiles again, and you test them on operational profiles. Just to have an idea, there are people that are only their job is just, for instance, optimize queries in a database. So this can be a full day job or a complete job for someone. So tuning a real application in demanding contexts is hard. So you need to test them in this type of context. And we're gonna learn how to use JMeter, for instance, to simulate sequences of requests that basically are related with these operational scenarios, okay, profiles. Stress testing is another thing that you can do. And basically here the difference between stress testing is to see how robust is the system when the type of usage is higher than the normal, than what you expect. Sometimes this kind of tests is not just to say that the system works okay, is that, for instance, it doesn't corrupt data in the database. Although you say, well, in this situation of stress, I don't mind if the system just shuts down, okay? Because we'll say that 1% of the time this is going to occur, and that's no problem if the system just stops providing service. But it's important that, for instance, I do not lose data. Okay, again, this is a matter of money, okay, and of cost, okay. You learn that 100% availability is quite impossible. Companies that have a 90.99% availability, like Amazon or Google, spend a lot of time, a lot of money to guarantee this level of availability, okay. So most of companies, they have software systems. In that stress, the stress testing is more in the sense of, okay, let's shut down smoothly or gracefully, okay? And finally, you have user testing. And here the key word, so if from this point, if from the point of view of release testing is business value, when you talk about user testing is the validation. So this is the final validation. And this is the type of test we have seen, like alpha, beta, acceptance tests, in the sense that are the final users that are testing. They are not just saying, well, they are not looking what is the requirements document saying, hey, the system is working according to the requirements document. What they are actually looking is, this is what I want to have. So suppose that we have all these Windows beta testers, or these are the guys that really say, hey, this is a better system, I want to use it, because they really do not care what is the specification, okay? So actually, here is in the user testing that you decide about the success of the system, not in the other one. Of course, you do other ones, just that you remove the bugs and you try to be closer to what is the needs, but the final needs is just the final user and the final client using the system and say, well, it fulfills my needs. Okay. I think that's all. Okay, thank you. Sorry, just a final remark that I forgot about to say here about these acceptance testing. So when you have agile approaches, this is actually the final or the real test. So the user is in the team. You don't have all these release testing, or actually you are really focused on the acceptance tests. So you don't have all these phases because actually you don't have a real requirements specification. Okay, and now I'm gonna finish. Okay, thank you.